This guide will show you how to set up PYNQ on the AMD University Program AUP-ZU3 board. I'll give you a brief overview of the board and show you how to prepare a bootable micro SD card with the latest PYNQ image. You'll see how to set up the board to boot from the SD card, attach cables you need and power on the board. I'll go through the boot sequence, and once the board is ready, you will see how to connect to the board using PYNQ and start exploring. The AUP-ZU3 has a Zynq Ultrascale Plus ZU3 EG part with a quad-core ARM A53 and programmable logic. The board is intended for university classroom teaching and student projects. Now we'll look at some of the peripherals connected to the ARM processing system, or PS. There is a micro SD card slot to boot the board, a USB-C port for JTAG or UART, two USB-C ports, one for USB host and the other will be used for USB gadget with PYNQ, a mini DisplayPort out, one Grove interface, two LEDs and one push button. On the programmable logic or PL side, there is a MIPI camera interface, audio in and out with an I2S audio codec, two PMODs in the PMOD Plus format with some additional pins, four push buttons, 8 slide switches, 8 white LEDs, 4 RGB LEDs, two Grove ports and a Raspberry Pi compatible header. See the user manual for more details. The board comes in two variants, either 4GB or 8GB of DDR4 memory connected to the PS. A sticker on the box and on the board should indicate which variant you have. To write a PYNQ image to an SD card, first download the zipped PYNQ image file for your board. You can't copy the image directly to the SD card. Instead, you need to use an application that can format and make a bootable SD card. There are many applications that can be used for doing this. If you're using Windows, we recommend you use the free program Balena Etcher as shown here. First, unzip the PYNQ image that you downloaded to get a .img image file. In Balena Etcher, select this image file, then select your microSD card as the target. Click Flash to start writing to your card. We recommend that you use a high-quality branded SD card, at least 16GB in size and preferably larger. Faster speed SD cards will be faster to flash and may give you slightly better performance when using your board with PYNQ. Larger cards will allow you to install more software packages or save more data to the card. If you're using a Mac or Linux, you can use DD to write the image. You can find full instructions for writing the image in the PYNQ Read the Docs. You can find the link to the documentation on the pynq.io website. To set up your board, take your microSD card loaded with the PYNQ image and insert it into the microSD slot on the front of the board. Insert the card as indicated. The socket is spring-loaded, so push the card in until you feel it click into place. Locate the boot slide switch at the top of the board. Slide it to the left to the SD position to configure the board to boot from the SD card. There are a few simple ways to connect to your PYNQ board. PYNQ uses Jupyter Notebooks, which you open in a web browser. To use Jupyter, you'll need to connect your computer to the board over a network. Let's go over your options. Option 1, USB-C to USB-C. If your computer has a USB-C port, you can use the cable that came with your board. Plug it into the USB-C DRP1 port on the board. This creates a network connection over USB-C called USB gadget. This is usually the easiest and fastest way to get started. Option 2, USB-A to USB-C. If your computer doesn't have a USB-C port, but it does have a spare regular USB-A port, you can still connect. Just use a USB-A to USB-C cable instead. It will work mostly in the same way as option 1. Option 3, you can connect to a network. You can connect the board directly to your network using a USB-C to Ethernet adapter that you can purchase separately. Plug it into the USB-C DRP2 port. You can then use an Ethernet cable to connect to an Ethernet port on your network. Or you can use a USB Wi-Fi dongle and connect the board to your wireless network. Connecting your board to the network lets it access the internet, and this is helpful if you want to download software updates or install new packages. Choose the option that works best for your setup and you'll be ready to start using PYNQ in no time. I'll assume you're using the USB-C cable on DRP1. When you boot the board with the PYNQ image, the board will appear as a USB Ethernet gadget connected to your computer. The board will also appear on your computer as a mass storage device called PYNQ USB. The other USB-C port we haven't mentioned yet is in the top right of the board and is used for power. A USB power delivery controller on the board negotiates with the power source to request 9 volts at 3 amps. You need to use a USB-C power source that complies with the USB power delivery standard and can provide 9 volts at 3 amps. This may be a USB-C port on your laptop or PC, or a power supply. A compatible USB-C power adapter is included if you ordered the board kit. Under typical operating conditions, the Zynq Ultrascale Plus device may dissipate up to about 12 watts. To manage this thermal load, a passive heatsink is pre-installed on your board. During sustained high-performance workloads, heat dissipation may exceed the capacity of this passive cooling. An active fan sink can be added for improved thermal management. The board includes a built-in fan controller and a 2-pin fan connector. See the user manual for more details. Optionally, connect another USB-C cable to the PROG UART port. If you are using PYNQ, you can use this to monitor the terminal as the board boots, or to run commands from the terminal once the board is ready. If you don't have a USB-C port spare, you can use a USB-A to USB-C cable again. If you are not using PYNQ, you can use this port to program the board over JTAG from Vivado or Vitis. Start with the power switch in the off position and connect the board to a suitable power source. The white USB power LED should turn on if a power source is detected. Once you have inserted your microSD card with the PYNQ image for the board and connected the other USB cable to DRP1 and set the boot to SD, slide the power switch to the on position to power on the board. Immediately after power on, the green on LED beside the power switch should turn on. After a few seconds, the two PS LED0 and LED1 should turn on, with PS LED1 flashing in a heartbeat pattern. This is a good indication that the board is booting. After about 30 to 60 seconds, the green Done LED will turn on. The Done LED indicates a bitstream has been downloaded to the programmable logic. The 8 white LEDs at the bottom of the board will flash and remain on, and the 4 RGB LEDs will also flash in alternating colours and turn off. The board is now ready for you to connect to it. You will be connecting to a JupyterLab web server which is running on the board. On your computer, open a web browser. The latest versions of Chrome, Firefox and Safari browsers are recommended for use with Jupyter. If you're using USB-C Gadget, the IP address will be 192.168.3.1. In your web browser, type http:// the IP address of the board, followed by /lab. This will bring you to the JupyterLab login screen. The Jupyter password is Xilinx, all lowercase. You are now ready to start using PYNQ. In the Jupyter Home area, you can browse to and open some example notebooks already included on the board. You can use these to start exploring your board and learn more about the PYNQ framework. Visit the Real Digital website for the user manual, constraints file and other resources for the board, and visit PYNQ.io for more information on PYNQ and to ask questions on the PYNQ support forum.